Hey, I'm Alice Egan, and this is SaaS Savvy, your online resource for thriving in the tech industry. SaaS Savvy brings SaaS and cloud technology back down to earth so that you can sell, market, consult, and design more confidently. Follow, like, and subscribe for more approachable tech content geared towards non-developers. In our last video, part 2, we learned about how remote web APIs use the internet to share, request, and receive information from front end to back end and from one app to another. We talked about how the baseline communications protocol of the internet is HTTP, and anytime you pull up a web page or do something like open up an account page inside Salesforce CRM, an API call is made over HTTP to retrieve the resources from the server for you and render them on your device's browser or in the app. In this final part 3, we're going to talk about the reigning queen of the API world, the REST API. As of 2022, REST APIs are still the most common web API out there, and we're going to find out why. We'll start with an overview of what REST is, delve a little bit more into what CRUD apps are and how they relate to HTTP and REST. We'll talk about why JSON is such a friendly format for data exchange in APIs, and round it out with why REST APIs are so popular and ubiquitous. And then finally, we will bring this 3-part API fundamental series to an end with a recap on why APIs are everything and everywhere. It will be no shock to you at this point that there are many kinds of web APIs. Streaming a show on Netflix may use a different web API than completing your payment via Stripe, and so on. APIs take many different shapes and forms, and you can see some common ones here like SOAP and the emerging GraphQL. But at time of writing, about 70% of the APIs available on the internet are REST APIs. How did this come to be, and what does REST mean? In the late 1990s and early 2000s, people started moving from accessing apps primarily on their local computers to instead accessing apps on the web via a web browser. APIs, as we now know, have been around for as long as software and hardware have needed to communicate, but many of the pre-existing APIs were designed for machine-to-machine communication. So none of the options available at the time were proving remarkably performant for these new web-based apps and sending data all over the internet. Programmers realized that they needed something more efficient and more scalable for this web app to web app phenomenon. Well, someone was bound to figure out a better way to send data across the internet, and that someone was this guy. In 2001, a computer scientist named Roy Fielding laid out his case for representational state transfer in what would become his seminal 2001 PhD dissertation. What he pointed out was that by designing web APIs to leverage the already existing design of the internet, they were way more performant, easy to use, and scalable. So REST is a set of guidelines for designing APIs for the web. Fielding laid out 6 constraints or guidelines for creating APIs that leverage the power of the internet. When APIs follow these guidelines/constraints, we call them RESTful APIs. Cute. Without going into every single guideline, I'm going to highlight the 2 that I consider most important for understanding the value of RESTful APIs: client-server architecture and a uniform interface. Number 1. Client-server architecture stipulates that REST APIs are designed to follow the standard client-server design of the internet. This means REST APIs take advantage of the HTTP protocol for exchanging data between client and server, and they get to use all the HTTP verbs that go along with it. We learned in part 2 that HTTP provides 5 verbs for a client to indicate what they want to do with the resource. These verbs allow a client to create, read, update, or delete a resource, and apps that allow for this are called CRUD apps. CRUD, this acronym, originates from database science and what users could or can do to data stored in a database. These 4 CRUD actions map to the 5 verbs that come with HTTP, and in modern software development, CRUD principles are mapped to REST commands so that REST APIs know what to do with the data that the API is sending. Think about an app like HubSpot, where we have contacts, companies, quotes, and more. We might want to update a contact's email address, create a new company to prospect to, or view a quote that we want to send to a prospective customer. For example, when I fill out a form to create a new contact in my HubSpot account and I click the Add button, that action fires off an API call behind the scenes to the backend that creates the contact with the data that I've entered. Since HubSpot uses a REST API, that API call uses the HTTP verb post. It indicates the URL of my HubSpot instance and talks to the contacts endpoint of the resource on the API. It indicates all the data about my contact that I've entered into the front end, and if all is good, the server responds with a 200, meaning all good, contact created on the back end. Most importantly, this client-server constraint means that clients always send requests to servers and servers always just respond to clients with the resources. It's that simple and it never changes. Clients and servers can both change or evolve independently without risking muddying the communications channels between them that they need to operate. This is obviously hugely important as software is always evolving and being iterated upon. The final constraint in the pack, uniform interface, stipulates that API designers make their interfaces straightforward and easy to work with. Simple as that. No application or server is written the exact same way, and without a standard way of reading and requesting information, every API call would get messy or fail or be a super manual process. We've talked about resources with Photoli and SaaS applications like HubSpot, and again, they often take the form of what a business does. Photos, customers, tickets, orders, chats. Each resource in a RESTful design must be uniquely identifiable and callable via a unique endpoint URI. A URI indicates where a resource lives on a server, and it must remain the same all the time, even when the resource itself may change. It may get updated, it may get deleted. So in RESTful design, the resources and endpoints should be simple and intuitive for a programmer to follow. And this last constraint also stipulates that resources are manipulated through representations. What this means is that clients don't interact directly with a server's resource. They interact with resources via a representation or a software interface. The data sent from client to server is always delivered in a neutral format. The server and the client are likely programmed in different languages, and this is why most REST APIs communicate between software in the JSON data format. Speaking of, let's talk about APIs and data formatting, specifically our friend JSON. APIs exist to send and receive data, and data needs to be formatted. It should come as no surprise that there is more than one way to format data. XML and JSON are two of the most common formats for sending and receiving data via APIs. REST APIs are most commonly associated with JSON, but REST APIs can also use XML. It's hard to talk about JSON without talking about XML, so here we go, very briefly. Before REST APIs were invented, in the 1990s, SOAP APIs were all the rage, as they were one of the first standards for exchanging data over the web. Data exchanged in SOAP API calls is an XML format. XML, as you can see on the screen here, is pretty verbose, meaning it uses a lot of characters and signs to package up and send data. But in a day and age where we love seamless, fast, and simplicity in everything that we do, it's easy to laugh at SOAP and XML as being these bulky, antiquated technologies. But with more stringent standards comes more stringent security. So SOAP and XML data formatting are still heavily used in the financial services and telecoms world, for example. But the problem with verbose data is that it just takes machines that much longer to process it. It doesn't move as quickly, and in today's world, that's the name of the game. As Tray.io puts it, REST APIs are the spiritual successor to SOAP APIs. As we've been talking about, they emerged as a super simple way to exchange data over the internet. And something that makes REST APIs so much friendlier and easier to use than SOAP is their heavy association with JSON. As you may be remarking here on screen, yeah, it's so much easier to read. REST APIs are associated with the JSON data format for sending and receiving information for precisely that reason. JavaScript notation, JSON, is favored as a message format because it can be read by any programming language, despite the name, It's human and machine readable, and it's lightweight, meaning it doesn't use a million characters to describe data like its rival format XML, meaning that it's easier and faster for a machine to process. REST APIs can also communicate in XML, making them just that much more flexible and winning hearts and minds. I would say SOAP and XML are like the older sister to REST and JSON. SOAP and XML are older, they set the stage for rules and curfews, and they're a little more mature and therefore better suited to serious situations. REST and JSON are the free spirit younger sister, a little lighter and less weighed down with being the first one. Easily pitted as rivals, they really just shine in different areas. And big shout out to my older sister, Emily. As I said, in 2022, somewhere in the range of 70% of the APIs available on the internet are REST APIs. Why? Well, since REST APIs are a set of guidelines for designing APIs that leverage the architecture of the internet to be the most efficient and scalable, it makes sense that a lot of software products choose to design and expose them. Many of the world's leading SaaS companies like Zendesk, Salesforce, Asana, Twitter, and more make REST APIs available to customers and partners either for free, included in the cost of an account or a license, or for a fee. And while there are some new players in the API architecture space, REST still reigns queen. So reason number one, scalable. Scalability in software describes an app's ability to grow and evolve without needing more resources and without negatively affecting performance. If an app doesn't scale well because of APIs and connections that are all over the place, that is going to mean it'll crash and bug out a lot as more people use it, and fewer people will likely continue to use it and certainly not pay for it. So because REST APIs are designed to facilitate communications between two pieces of software and revolve around this independent, i.e. decoupled client-server architecture, changes or evolution to software or servers won't mess connections up. Having stable, reliable connections to share data within an application and between applications is crucial to an app's scalability, and REST really takes the cake here. REST APIs are flexible. Want to send data in JSON, XML? Want to include additional layers of logic or security? REST APIs are built to give developers options and help them handle both new and legacy tech stacks. And finally, web standards. HTTP, JSON, URLs, URIs. As we've said, REST APIs leverage the power of the internet to make sending and receiving data over it way more straightforward than it had ever before been. REST APIs are not the end-all be-all of APIs, and more types of APIs are emerging out of big tech companies like GraphQL. But at time of writing, REST APIs are still the standard and fan favorite. All right, let's bring it home. APIs and REST APIs for sure do great things for developers, software, and us end users. APIs integrate systems and automate processes. They allow for data sharing, and they allow us to extend the functionality of an app and make better experiences for us all. APIs massively benefit API providers, meaning the company or product who make an API available to others for use. So first off, money, revenue. There are hundreds of free APIs on the internet, but they're mostly for looking up the weather or searching for automated cat jokes. SaaS companies have monetized the hell out of their APIs, and for good reason. They bring in the paper. Whether it's increasing total account value for access to greater API functionality, or partnerships with key companies to build revenue generating integrations, opening up an API unlocks business opportunity. Even companies who don't charge for API access generally increase revenue by positioning themselves as companies and business partners who are open and ready to integrate, and putting customers in a position to be agile, innovative, and forward-thinking. Scale. B2B SaaS companies want to create their own kind of network effect. Beyond just having a devoted customer base, getting developers bought into the merits and usability of their software is key. If developers like working with the software or developing on its reliable platform, they'll go to bat for it. The best case scenario is that so many devs love your software and platform that they build apps that they want to share with others, and you've got yourself a marketplace. Salesforce is a great example of using APIs for scale. They started out as a Salesforce automation SaaS product, but released the Salesforce.com platform a few years later. With their platform play, they've now got an ecosystem of thousands of developers who build, sell, and ultimately evangelize Salesforce to other customers through their own channels. And finally, APIs bring even more innovation than a company might think. So we've talked about how companies and developers can take advantage of third-party solutions that help them cut corners or embed best-of-breed technology over having to build something from scratch. Makes sense. But it goes in the other direction too. Third-party solutions are sometimes born from a total lack of functionality in the market. A third-party developer may build an app because of a feature gap in an existing solution. The third-party developer makes money every time someone buys her app, and the software she's built for it can win more deals for the product with this additional functionality. So that's a win-win. And we'll round it out with some benefits of APIs to API consumers or the people or software who use APIs. And like I did previously, I'm going to talk about these upsides from the B2B software perspective. Productivity. As we've talked about today, companies are major internal API users as they build out their products and run their businesses. Outside of the APIs crucial to an app just working are the APIs across internal tools and systems at a company that allow for exchanging a ton of data. When different parts of a business can expose data from their own tools and systems and make them available to other areas of the business, a company can streamline operations across this plethora of tools and apps in use, foster a culture of collaboration, and strengthen transparency across a large organization. An example of this API-first culture comes from Amazon, where an alleged email coined the Bezos mandate outlined the CEO's demand that all software and services developed at the company could be exposed to other parts of the business. This would inevitably pave the way to Amazon Web Services in the cloud, a topic for another video. But in any other business sense, let's say a data team in a company is in charge of collecting data about customer retention, and sales operations is tasked with figuring out who they should try to bring back after leaving for a competitor, i.e. churning. If the data department doesn't make that data readily available to other business units, it's hard for sales ops to figure out who would be a good target to get sales to re-engage. But if teams follow a Bezos-style mandate and open up their data across the company, the business as a whole can operate more efficiently. User satisfaction. Companies obviously want to be the best they can be for their users, but they can't be everything at the same time. By being able to use APIs to integrate best-of-breed technology into their apps instead, users get a better experience. Whether this is Uber building their ride-sharing app while leveraging Google Maps via API for geolocation, or ASOS.com allowing you to pay via PayPal or Klarna, APIs allow one company or product to leverage other technology to provide a better service to their customers. And finally, innovation. We've said it 80 times, but we'll say it again. APIs make developers' lives easier. Internally, they can access information without having to get down into the circuitry. And just like integrating third-party software via API can provide a better experience for customers, it also saves developers time. They don't have to build everything all the time on their own. And this ultimately leads to greater developer innovation in their own space as they have the time to focus on what they've been tasked to build or on what has not yet been built. And that's it for our final video in our series on the fundamentals of APIs and software interfaces. Oh my gosh, we learned a ton in this series, all the way from defining APIs in general to visualizing software interfaces, recapping how the web works, and learning about how REST APIs leverage the power of the internet to become the most widely used API in the world of Web 2.0. You officially know enough to be dangerous, no coding required. Thanks again to all of my sources included in the video comments below. And again, follow, like, and subscribe for content that brings SaaS and cloud technologies back down to earth so that you can sell, market, consult, and design more intelligently and more confidently. Thank you so much. I will see you next time here on SaaS Savvy.